Hello and welcome to another video on the front-end system design. And specifically, we're going to take a look at the application state. All right. So this particular section, right, of this is one of the responsibility that we have as a UI specialist when it comes to design this front-end applications. So when you need to build features, there are several areas that you need to take care of, right? So one of them is how we're going to communicate with the API. Understand first of all is what is an application, what is the anatomy of the applications. You have the front end, the API, and the back end, all right? And how in today's video and in this particular course, which solely focuses on front-end system designs, is as a way to look at what are the fundamentals that we need to know as a way to build these complex, large scale applications. So because we are now described as we are now actually is looking at this particular area responsibility, right? So first is the API communications, how we're going to communicate with the API, something that we're going to see in the next videos. Also is how we're going to now manage and how we're going to store and manage our data, which is what we're going to see in today's videos, this data management. And then how can we now provide some of this particularly complex or cover this complex user interface or user interactions, okay, based on a particular use cases. So we have now the observer, which is part of this web API that it provides us by the browser as a way to cover specific use cases, right? That's why you have the intersection observer, the mutation, and the resize observer. All of this help you to, for example, in the context of intersections, as a way to solve these virtualization problems, right? How you can now is using this technique as a way to make as a way to now, once you store all of the data and show a subset of elements on the DOM, because the idea here is to minimize is the number of render elements as well as the mutation that we need to do to them. Therefore is the CPU and the memory. So this is one of the example of how can we use intersection observer for that. And the other is for analytics. So we want to know is how many time a user is actually looking at this particular piece of content, whether it's an article or a visualization, some sort of dashboard or page, right? And also when you want to load now data dynamically, right? Lazy loading, or you want to now add in or loading is component as you go, right? This is the use case that covered the intersection observer. If you're implementing is a text-rich editors or a drawing tool, mutation observer helps you to do that. Or if you are, for example, now working with SVG elements or creating is a charting or implementing a charting tool, or you need responsive designs based on that charting tool. So you want to show now this particularly element or this particular chart, especially useful for trading. You want to show now this particular chart across different viewports, mobile, tablet, desktop, you know. So you can use now is the resize observer. So I mentioned all of these particular cases, in all of these use cases in the tool, because this is just to cover is most of these common user interactions. complex user interactions. And also we need to handle is how we're going to is use and handle the assets, HTML, CSS, and JavaScript, fonts, image, right? So, because what we really care into this video is the how we're gonna store and manage our data, which is now the UI state management, which is a course taught by Yvonne Ray, right? As you can see here, right? Yvonne Ray, a software engineer in that Jesus, sorry. I have a lot of caffeine in my body. That's what happened. And I know and I feel it, man. And I feel it. There is also a reason why I'm talking a little slower, because I have a lot of energy inside of me that I want to actually canalize it. I want to channel it properly. All right. So yeah, Yvonne Ray, okay, software engineer that has previously worked at JetBrains for 3 years, and now he's currently working at Meta, and he actually made this for us. So the idea of this also is to find a way to organize all of our data, all of our education, all of this content, and make it meaningful not only for ourselves but also to others. So because we're not going to dive too much in all of this particular concept, so for example, like the core fundamentals on API and web API complex, not to mention the virtualization, this is something that we already saw, that this is what we really care about this. So how can we now store how can we now build a UI in our applications? And for that, we need to know is what are the data that we want to store. So this data, most of the time that we want to store, has two properties. It is the type or the class, right? The type of a class, and it is properties. So for the type of class, usually we have is own data for app configurations, which is the user themes or the locale accessibility fonts, right? And also we have now the local state that we need to handle, these UI element states. So for example, selecting a checkbox or selecting a text, something that you can do here in Google, right? And then apply some of these particular events or interactions, right? So we need to have that particular data, and also the data that come from the server. For example, if you're implementing is a chat application, you need message, or if you're sending a message, or if you are posting message or posting content, you also need to handle that. So each one of these particular data, classes of data in UI development has its property. And this property is one of the end goals of all of this application state. In other words, knowing the property of this one of these data will allow us to now set a goal of how we need. So what are the things that we need to do to manage our state, to store the data and manage this? How, in other words, data management. So what are the things based on this data that we need to classify and store, as well as manage, and it is property. So we now come up from here and say, hey, this is now the goal of data management. And because database engineering has a lot of time doing this. They have from the 60, right? That's why we have now relational database, and then over the years in the 2000 then come up with this now solutions, which is from no relational database or key value pairs, such as Redis and also graph databases. But all of this is just as a way to cover a specific use cases. So here we are, right? So now that we understand what is the classes of data that we want to store and handle it, and it is properties of each one of those data, so we want us to now put some have an access layer of each one of those data. Who can have access to this to this kind of data? How frequently do we want to access to this data, read and write this data, and how can we now decide where we want to store this data? Because it can be big. So what is the size of this data as a way to determine when do we need to store, right? It's not the same that you want to store, for example, in a backpack, books and your MacBook, then carry 15 pounds or 15 kilos of bricks, right? If you depend on the task, depend of what do you want to do with that, you are going to use a particular tool. So for example, if you are in construction, you are going to use this a wheel how do you put it, construction wheelbarrow, right? Oh, it's called a road construction. Okay, road construction, wheelbarrow. I didn't know about the name of this. That's also the reason why I'm doing all of this kind of thing. It's like wheelbarrow. Oh, great, interesting. Wheelbarrow. Why barrow? What barrow means? Two wheel. Oh, this is US. This is British, by the way. Barrow. A vehicle moved by a person from which fruit and vegetable. Barrow. Usually to wheel a small. A vehicle moved by a person here. Wheelbarrow, but barrow.
Barrow.
Here we go with A. Barrow. Oh my God. Anyway, I say barrow because I have a Spanish root, and we say A like A, no A, no A, and we say A like not A like A. Anyway, okay, barrow. Wheelbarrow. A flat rectangular frame used for carrying a load. Okay, a flat rectangular frame used to carry load. Oh, that's quite interesting. Hand barrow. What is a hand barrow? Do you have any image for a hand barrow? Some rectangular place where you can load that? Hand barrow. Okay. Hand barrow, wheelbarrow. But in any case, exactly. The idea of this is to being able to describe this particular property with real life example, especially when you need to understand what is a date. understand what are the property of this data, all right, that you're storing here in a wheelbarrow, all right, for example, or in your backpack. Okay, so what is the type of data? What is the class of data, the class of payload that you're putting there? In this particular case, this particular payload is very specific to the UI development, which can be configuration object, what can be is states, UI state in elements, or UI element states, or server data. Okay, and it is properties, right? So it means that what do we want to do with this kind of data, right? So we want is to prevent someone who can access to, similar in a wheel row, when you put, for example, let's say a chainsaw, you want to cover that. So for example, kids can get in there and chop up their fingers, right? You want to protect that access, right? Access level. The other is the access level. The other is on how frequent you want to get into this data, right? How frequent you want to get access or retrieve some data, read and write of data, right? So how often you need to actually get into this wheelbarrow and actually use an access to the chainsaw, cut off, turn off the chainsaw, because we're quite close to Halloween, scare a lot of people out there, right? And then once you're done, well, you store that. Again, that was a bad joke, but in any case, how often you want to do that? And the other is how heavy is this data, that we are putting in this place and we're storing here. Okay, and because of that, we have now different tools that we can handle that. So it's not the same. It's not the same that we're gonna put all of this brick, 10 kilograms of bricks on a wheelbarrow, which is much more easy to carry on, transport, than putting that in your backpack. All right. Again, you're going to strengthen your back, which is something that you should do by hitting the gym. But in any case, here we are. Okay, so understanding these particular properties, all right, and when we need to actually look at an example, all of this property that we describe is because we want to know, in the context of UI state applications, is to minimize the access. We want to minimize the cost of accessing data, search, in memory usage, right? So we wanted to minimize is how many times do we access to it. We wanted to minimize is the cost of accessing this data, access this data, or access this data, search on this data, and store that. All right. We minimize the memory use. So because of that, okay, so we look now at a particular example, which when
let's discuss the location this is a message with ID plate, but
when Evening Ray actually tried to explain, it's quite confusing and it's very hard to grasp on. It's not too didactic, right? Pedagogy is something important, as you can see, as you can imagine. But this is right. We want is to now minimize the data access costs. So, example, a chat app, right? Example is into example minimize access costs. Okay, there you go. Minimize access costs. Here we are. Exactly. So this is a chat app, right? So let's see how can we minimize access costs, right? And in this case, by using a technique called normalization, which is something that predates JavaScript, since it is a concept from the 60s, right? When database engineers wants to figure it out a way on how to organize data to prevent how to organize data in a way to reduce in a way to improve access time and eliminate redundancy, okay, and eliminate redundancy and duplication. So because of that, okay, so minimize access costs. So because of that, all right, so you can see what will happen is that in your contact you need to actually access to that, and then that will hold the conversation, and then
way, because if we have potentially thousands of messages, then we need to traverse the whole array just to access single element. This is not the way we want to design our app. And so the first to access single element, this is not the way we want to design our app. And so the first technique that we can use to optimize the messages. So this is although acceptable, it's still not the best way, because if we have potentially thousands of messages, then we need to traverse the whole array just to access single element. This is not the way we want to design our app. And so the first technique that we can use to optimize our data is to change how we store it. And there is a concept called data normalization. So the data normalization has been around for, I think, 20 or 30 years already. So it's a concept used in the databases heavily. The goals of data normalization is...
So this is now the goal of database normalization. So we can actually put this. All right. So even though that this is acceptable, right? As you can see here, come on, man. Exactly. Even though that this is acceptable, so you can have now a state that it contains contact, and then inside of the contact, which is a collection of them, you have now is message, where this message is also is a collection that has now is the message for that. But the idea here is to minimize access cost by using is now this particular techniques, okay, which is normalization, minimize access cost through data normalization. Okay, so yeah, the idea is to optimize, also to improve the access time, optimize now the way how we're going to store that data, and improve the readability and maintenance.
To provide optimized access performance and also provide the optimized structure how we store the data. And if we have a unified structure how we store things in a state, it increases the readability of our code and further maintenance. And the data normalization operates with the normal forms, where there are in total 7 normal forms, and the more the farther you go, the more you normalized. In the UI apps, we usually utilize only 2 or 3 normal forms, and let's go for the process of data normalization. So if we take the first example, where we have a simple object with the ID and name, and then it has the job and the location. So right now it's a non-normalized object. So we can optimize this by applying the first normal form. And what the first normal form does is tells us that every field on your object should be atomic. So we need to convert.
Okay. So to do this, we use this normalization, okay, technique that is made of 7 layers, right? But in the front end, we use only 2 normal forms, right? Okay, so the first normal form is with the first formal norm, right, is to say data is atomic and has primary key, right? Again, data is atomic and has an ID, which is part of this index. And has a primary key, right? An ID.
First normal form. And what the first normal form does is tells us that every field on your object should be atomic. So we need to convert to reduce any nesting in our objects. So we just flatten the nesting to the second normal form. And what the second normal form does, it tells us that all our fields now should ideally depend on the entity. So if we look at the following fields, the job ID and job title, the job title actually depends on the job ID, although it also depends on the on our user object. So the data normalization tells us that we need to decouple this into the separate table in the database concept, but in our case, it will be the separate object. So we move our jobs, we move our job to the jobs table, and what the first normal form does is tells us convert our first normal form to the second normal form. And what the second normal form does, it tells us that all our fields now should ideally depend on the entity. So if we look at the following fields, the job table in the information ID.
So is that so all the data? So the second form is that, right? So the second form normalization. Okay. Let's go to put this. What the French toast? No. So the second form normalization says normal form plus all, so data data must depend on also non-primary keys. Okay, so non-primary keys, which is other data, other data, depend on entity primary key. So now things started to make a lot of sense. It's like all of these keys that are not primary, they must depend on the entity. All right. So a good example of this is, hey, is this non-primary key is depending on this entity? Which means is like, for example, you have a user. Is this depend of this? Is this non-primary key actually depending of this entity? If it is, good. The TLDR of this is that this data must be relevant to this. Okay.
Oh, actually, yeah. They also we moved the countries to a separate table. There is a third normal form that.
And the third normal form, let's say, hey,
tells us the main difference from the second one. We say that non-primary keys should depend on the entity primary key. But the third normal form enforces this rule, saying that it should depend only on the primary key. And the difference is very subtle. So if we look at the UI job, it has a title and department. So department really might not be directly related to the UI or to the title. So we want to decouple that to say, okay, the department should directly depend on the.
Exactly. So non-primary key only depend on the entity primary key. Oh, non-primary key only depend on the entity non-primary key. Should depend on the entity okay. Oh, okay. And the third, okay. And the third formal norm, okay. That's way interesting. Okay. You got it. No, you're not gonna put that right. No, you're gonna put that right. Okay, no problem. And the third formal norm, right? In this case, and the third formal norm say, hey, this is the second normal form. French toast. This is the second formal norm. Okay. Okay. Yeah, this is the second formal norm. Plus non-primary keys only depends. So non-primary key only depends on the entity primary key, on the entity primary key. Interesting. So it's all of these non-primary keys, all of data that is related to this entity must depend on that
UIE ID. So we move the department to additional table, and now we can access the department type by providing the job ID. So this step, the third normal form, sometimes is excessive so it's usually on the UI we use the second normal form. So it's up to your case if you want to apply.
Exactly. Usually this second formal norm is more than enough right now in front-end application.
So if we go back to our messenger example, let's try to convert our non-normalized data, the state of the.
Okay. No, okay. So now let's gonna make an example, right? Example. Example. So we're gonna transform now those. The first note we say all of this field must be atomic. Okay, so all of the field must be atomic. That is atomic in it has a primary key. So in our case, is this one is atomic. That's right, except for this. Right, so we're going to create a new table of message. All right. Yeah, that's right.
Messenger to remove the conversation and the messages to second normal form.
Exactly.
So first, we want to reduce the nesting. So we want to remove the conversation and the messages
to its own entity.
So a new type called conversation, which has the ID and the title.
So conversation, we're gonna get out of from that. You're gonna transform it into an ID, where we need to append that to the message.
And we also remove the messages from the conversation. Now we identify the primary keys. So for the contact, it will be ID. For the message, it's a message ID. For the conversation, it's also ID. And when we store these fields on the global state, so now to access the message with a certain ID, we just provide an ID, and it will return us the message. The same for conversation and for the contact. So for the contact, it will be ID. For the message, it's a message ID. For the conversation, it's also ID. And when we store these fields on the global state, so now conversation. Now we identify the primary keys. So for the contact, it will be ID. For the message, it's a message ID. For the conversation, it's also ID. And when we store these fields on the global state, so now to access the message with a certain ID, we just provide an ID, and it will return us the message. The same for conversation and for the contact. So although you still may notice that to find specific message in the contact,
even though to find a specific element, right? Even though to find a specific message here, we need to rely on a search through that. Or we need to rely on query such data.
Right, we still need to traverse all the messages. How can we optimize even that? So let's move on to the second principle, minimize the search cost.
Exactly. So to minimize the cost of searching data in our UI or in our front end, okay, we now move to the second principle, which is minimize search cost, So minimize search costs. Exactly, which is minimize search costs. which is minimize search costs.
So we could potentially build a new an index table, which will be called inverted index table. It's called inverted because the content of the entity becomes the key in this sense. So what we're gonna do, we're gonna extract all the
Exactly. So there are, okay, there are several ways, but there are several techniques to do this. Index is one of them. An inverted index table. Okay, but this is as a way to minimize the search costs. So we have index and we have inverted index table. Holy crap. That's one of the reasons why we are looking at this, right? Inverted indexed here. Inverted indexed. Inverted indexed. Inverted index table. Where the content that we store is in our key, and we have a reference to that.
Words from the message content, and then we're gonna build the index table where the key is the word from the content of the message, and we're gonna store the ID of the message where this message where this content appears, and the timestamp that will help us to sort out the search.
So where the content that we store is with the content that we store in our key. So where the content that we store is exactly where the content that we store is the key, and the value is a reference to that index. It's a reference to that index row. In this case, the message makes a lot of sense.
Results as in the timestamp order. So later, we can utilize some asynchronous job to build this inverted index table. This can be a web worker that will access the IndexedDB and store it in the storage, or it can be you can use the idle cycle of your event loop to build this index table in your application. But you may notice that, okay, I can search by the word, but what if I want to search by the prefix? Can we improve it even further?
Okay. Okay. So, and then you can use a worker or async job to search in a storage, whether it is IndexedDB, or local storage, or a cache here. Okay. Yeah, then you can use a worker or async job to search in any storage, IndexedDB, local storage, and cache. To access that, to look for it. But what if we want to improve per prefix? This is when it comes to try here.
And apparently we can. We can build composite keys. We can use the composite key for the inverted index table. So now we're going to store all possible prefixes of the word and keep the message ID and the timestamp. So if we type in the search bar, for instance, GA, this will give us all the messages that where we saw the GA in the conversation.
Exactly. So now we're going to have things with this. All right. So thanks to this composite keys that will hold is the prefix of that content from the inverted simple keys, we can now access to that message row, because it's holding the reference in there, because it's holding those references there in memory.
You may notice that the composite key itself, so we can store in JavaScript the string as array, because the key should be always a string. That's where the storage comes in. So let's.
Mm-hmm. Well, actually, map allows you to do that. Map in JavaScript. No, because you have to be unique. Yeah, it has to be unique. Yeah, but it's unique values. Exactly. Mm-hmm. So in our objects here, object prototype properties, deleting null properties, constructor, this is a description, null prototypes. Call instance of primitive values, undefined, boolean type, number, but this is the structure here, and objects. Okay. It's a collection of property which obey literal syntax, that kind of thing. Data property, value, writable. The value retrieved to be get access can be any JavaScript value. Can be any JavaScript values, but not an array, as will happen. Unless you store a string to an array and then you try to actually do some exactly.
First, so we can store in JavaScript the string as array, because the key should be always a string. That's where the storage comes in. So let's first understand, so before we discuss the storage, let's understand how we're going to manage the memory. So, yep.
So in this example, there's just 2 messages, but in theory, if you had like multiple messages that started with hey, those would all end up under that single, either
so
composite key.
You would have multiple tuples here.
Okay.
So the inverted index table may become large. So for instance, we may have already 1,000 of messages in each conversation thread. So we don't want to blow the memory of the device. So the way how can we optimize that is, so right now we have the conversation with John, but we know that there are two more conversations that are not active. So we can't just select them from the state, since we know exactly the conversation IDs, and we also know the we know the conversation ID, and we can filter out the entries. Now what we can do, we can outsource that to the separate storage. So we move this element to the separate storage, and we basically sharded our data. So it's basically the database concept, separate storage, to know the that are not active. So we can't just select them from the state, since we know exactly the conversation IDs, and we also know the we know the conversation ID, and we can filter out the entries. Now what we can do, we can outsource that to the separate storage. So we move this element to the separate storage, and we basically sharded our data. So it's basically the database concept in the browser, where in the database you don't have the single large DB instance. So you have a shards, and you store your data partially in multiple shards. And when you do the query, you're actually querying from the different shards. The same way happens here, but we limit it to two shards. One is our global state, which is runtime memory, and the second one is our hard drive. So when we move elements to the hard drive, we let the JavaScript engine to utilize all the objects from the memory and free up let the garbage collector free up the space. And for instance, if we selected the new conversation and we want to load the data back to the store, we can utilize the storage to just populate this back to our runtime memory. And we're basically going to swap back and forth the data. And now the question is, what type of storage should I use to achieve such behavior? And let's do the quick overview. So the browser storage API provides three types of storages for us. It's the IndexedDB, local storage, and the session. We limit it to two to store the separate storage. We know the conversation. It has multiple tuples here.
Okay.
So the inverted index table may become large. So for instance, we may have already 1,000 of messages in each conversation thread. So we don't want to blow the memory of the device. So the way how can we optimize that is...
Okay. All right. So because we can have thousands and thousands, thousands and thousands of, because we can have thousands and thousands of message in our device, and we don't want to blow up, we don't want to blow up the memory. We can use we want to blow out the memory. We need to find a way to only store the data that we need in our memory and outsource the rest of it. So when the user click on a conversation, we can now load that data from the outsourcing storage to memory. Essentially, we are going to do this. We're going to do this swapping. So this is for chat applications, but if you want to do that now for e-commerce applications, okay? If you want to do this for e-commerce applications, all right, where you want to show only something that is relevant to the users Especially when you want to show some products, right? For product recommendations. Okay, but this is now scalable problems. This is now scalability problems.
So right now we have the conversation with John, but we know that there are 2 more conversations that are not active. So we can't just select them from the state, since we know exactly the conversation IDs, and we also know the...
Exactly. So in this case, what we're doing is just outsourcing. But this is a specific for chat applications, right? For things that you want to outsource them. Okay, essentially we want to do this. Essentially we want to do this swapping. Okay. An application state memory offloading. So if we want to now outsourcing data that is not relevant to the user, since we have now IDs, we can is shard meaning we can is shard what we can is shard. Okay, shard. We can is sharding. Sharding. Exactly. So we can is split that. Sharding. So we can is split that. So we can split that. This process of partition a database which is used, for example, to deliver a data based on user location, okay, is known as a partition is known as sharding. That's right.
We know the conversation ID, and we can filter out the entries. Now what we can do, we can outsource that to the separate storage. So we move this element to the separate storage, and we basically sharded our data. So it's basically the database concept in the browser, where in the database you don't have the single large DB instance, so you have a shards, and you store your data partially in multiple shards. And when you do the query, you're actually querying from the different shards. The same way happens here, but we limit it to 2 shards. One is our global state, which is runtime memory, and the second one is our hard drive. So when we move elements to the hard drive, we let the JavaScript engine to utilize all the objects from the memory and free up let the garbage collector free up the space. And for instance, if we selected the new conversation and we want to load the data back to the store, we can utilize the storage to just populate this back to our runtime memory. And we're basically going to swap back and forth the data. And now the question is, what type of storage should I use to achieve such?
So what type of storage should I use to do this, right? because here we're talking about is to minimize is the search cost. So this is now minimize size usage. And well, this is something that I'm quite familiar with. This is something that I'm quite familiar with. For example, user preference you usually store is on a local storage. All right. Non-persistent data in local storage. Large data with query support using IndexedDB. Offline mode using IndexedDB, of course. High reads and write IndexedDB, and multiple storage support as well.
Storage and the session storage. So the session storage is good for storing some small non-persistent data. So it stores things only for one single session. When the user closes the website, the session is destroyed, and you don't have any, and the data is wiped. The local storage, on the other hand, is good for storing small things. It can be user preferences, you can also store non-persistent data and discard it if you want. But the local storage provides persistence. But the problem with the local storage and the session storage, they only support the string type and they are synchronous. So if you have a data that you expect to read a lot and write, then you will block the UI for it, and it will impact your application responsiveness. So what do we need to do to re-implement the behavior we discussed previously on the slides? So the IndexedDB, on the other hand, has the almost unlimited storage capacity. On average, it's 3 gigabytes. And it also supports indexing. So we can create a composite index we discussed and store the key as a set of prefixes. And we can actually enable this search using the IndexedDB. So we can utilize this index. And also the IndexedDB supports multiple type of data, which is very useful when we store complex objects. And it's also non-blocking. So it uses the so it's asynchronous. It means that we will not block the UI thread in this case. So the summary for application state design is, first you need to know your scale. Always start with the way how you structure your data, and use normal forms to provide optimized access cost, and use indexes if you're planning to do the search operations in your app. If you think that you will need to store a good amount of data in your state, then offload the data to a hard drive. For us as a developers, it's basically the free space that we can use, and it will improve your responsiveness of persistence. Create also the the summary for.
It's a JavaScript-based object-oriented database. What index lets you store and retrieve objects that are indexed with a key, and then it's supported by structured clone algorithm. Can be stored. You need to specify the database schema, open a connection to your database, and then retrieve and update the data with a series of transactions. Mm-hmm. 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 Browser storage and evasion criteria. What technology store data in the browsers? Mm-hmm. 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 Okay. Oh crap. So the TLDR of all of this, right? Is that so know your scale and optimize accordingly. So know your scales and optimize accordingly. Always start with how you structure your data. So what are the class of data, how you're going to store and manage. Use normal fold if you want to optimize access costs. Use inverted index table, or use indexes if your app search is required, and offload data to hard drive when it's needed, and pick a suitable storage, man. Holy moly. That'll be all for this video. Take care. Bye bye.